So, welcome once again to our discussion on multinomial regression model, right? That is what we are discussing. So, this is multinomial regression model. And in short, this is MRM, multinomial regression model, right? And we said that in multinomial regression model, basically your dependent variable assumes more than two values. So, that means it is a polycotomous choice variable, right? Instead of being the bivariate situation which we have discussed earlier in the context of logit and probit model. And then this multinomial regression model, basically it is of two types. Firstly, the nominal multinomial regression model and the ordinal one. In nominal, the choices are not ordered, that means there is no value judgment attached, but in the context of ordered MRM, the options are ranked or ordered according to their preference or value. So, we started discussing with nominal multinomial regression model, right? Nominal multinomial regression model. So, this is M, this is nominal, and this is ordinal. So, within nominal we have multinomial logit model MLM or conditional logit model CLM or mixed logit model M. Instead of mixed, I will say that this is mixed or nested multinomial logit model. This is sometimes also called as nested one. And we started discussing with multinomial regression model, multinomial logit model. So, this is multinomial logit model, okay, and our model was pi I j, which is basically probability that the ith individual chooses the jth option equals to e to the power alpha j plus beta j xi divided by summation e to the power alpha j plus beta j xi, where j running from 1 to 3. Okay, this is our model. All right, and we said that here the j subscript is attached with the parameters alpha and beta because the parameters they vary across choices. So, here if we have three choices, let us say the example what we are talking about, a +2 graduate is thinking about to go for a 2 years college or 4 years college or no college. So, that means the individual who is not opting for a 2 years college obviously attach a differential weightage to, let us say, the income variable as compared to the individual who is actually opting for the 2 years college. Okay. So, that means that the coefficients vary across choices 0 college, 2 years college and 4 years college. So, depending on what weightage you are attaching to a particular explanatory variable, either option 1, 2 or 3 would become most probable to you. Okay, that is what it means, which is not like the case earlier, right. So, that is what we need to think in mind, that here alpha j, since the j is basically j stands for choice. So, our coefficients alpha and beta they vary across choices, right, across choices. And in multinomial logit model, we are trying to explain why this is again basically chooser specific data. So, that means depending on individuals, socioeconomic and demographic factor, they will select either option 1, 2 or 3. All right. And we said that we are considering pi I1 plus pi I2 plus pi I3 equals to 1, sum of the probabilities equals to 1. So, that is why instead of estimating these probability individually and separately, which is actually not possible, the moment we estimate pi I2 hat or pi I3 hat, pi I1 hat would automatically be estimated by this property, which is equals to. So, from here what I can say that pi I hat is basically 1 minus pi I2 hat minus pi I3 hat, right. So, one category we have to always take as base, and other two categories probability will always be calculated in terms of the base category. Okay. So, we said that pi I2, if we assume that pi I1 is the base category, if we assume let us say pi I1 or first category is base, then what will determine? Will basically determine pi I2 by pi I1 and also pi I3 divided by pi I1, and this is basically you have to take log of this, and that would become alpha 2 plus beta 2 xi, and this would become alpha 3 plus beta 3 xi, okay, plus beta 3 xi. So, and let us say this is equation 1, this is equation 2, and pi I1 equals to 1 minus pi I2 minus pi I3 is, let us say this is equation 3. So, we have to estimate these equations simultaneously. So, we have to estimate these equations simultaneously. Using maximum likelihood method MLE. Now, the question that we raised yesterday towards the end, equation 1 and 2, equation 1 and 2 look like bivariate logit model. So, this is like bivariate logit model, because if we recall, in bivariate logit also what we are estimating, log of pi by 1 minus pi equals to alpha plus beta xi. That means, in bivariate logit model, we are basically estimating the probability of the relative probability of success over failure. Here, what we are estimating, the relative probability of a 2 years college over no college, and in equation 2, the relative probability of a 4 years college over no college. So, 1 and 2 looks exactly like a bivariate logit model. Then the question what we raised, is it possible Is it then possible? Is it then possible to estimate estimate 1 and 2 individually applying bivariate logit model? Okay, using bivariate logit model, and the answer is basically, answer to this question is no. We cannot estimate these equation 1 and 2 individually and independently using a bivariate logit model. Why this is no? Okay, why bivariate logit? Bivariate logit is not applicable for the following reasons. For the following reasons. What are those? Number one, that if we estimate, so that means estimation of individual estimation of 1 and 2 involves different sample size. For example, if we estimate equation 1, that means what we are estimating? Probability of a 2 years college over no college. So those who have opted for a 4 years college, their information is not there in this equation. So from the entire sample, those observations will automatically be dropped. So if we estimate equation 1, those opted for 4-year college will be dropped. Similarly, if we estimate 2, if we estimate 2, then those opted for 2-year college will be dropped. Okay, so that means equation 1 requires only that part of the sample. Equation 1 involves information from those individuals who opted for a 2-year college. Equation 2 involves those individuals who opted for a 4 years college. Okay, here we said that 2 is for 2-year college and 3 is for 4 years college and 1 is for no college. So that means estimation of these equations individually involves a different sample size, which is actually not desired. That is the first reason why bivariate logic is not applicable in this context. Then secondly, second reason, if we estimate equation 1 and 2 individually, applying bivariate logic, there is no guarantee that the sum of estimated probabilities which is basically pi I 1 hat plus pi I 2 hat plus pi I 3 hat, the sum of estimated probabilities will be 1. There is no guarantee for that, because I am considering them an individual equation and I am estimating from a completely different sample size as well. So they are like estimating an equation from a given sample size, they are independent, and as a result of which when I take the summation pi I 1 hat plus pi I 2 hat plus pi I 3 hat, there is no guarantee that this sum will be equals to 1. That is second reason. And the third reason is that generally the standard errors of the coefficients estimated from bivariate logic model are larger than those estimated from multinomial logic model. So if we estimate the equation separately applying bivariate logic model, then the standard errors of the coefficients of the coefficients estimated from a bivariate logic model are larger than those estimated from the multinomial logic model. So these are the three important reasons for which these equations, even though the multinomial logic model ultimately reduces to equation 1 and 2 which look like a bivariate logit model, we cannot estimate them separately. We need to estimate these three equations simultaneously. That means we actually have to estimate a multinomial logit model applying the maximum likelihood method. That is the reason. Okay. So this is what we need to know before we actually proceed for the empirical estimation of a multinomial logit model applying a data set.